Hi, my name is Mark Cantrell. I'm an applications engineer with the Isolation group here at Analog Devices. Today we're going to be talking about three of our new iCoupler products that include ISO Power. For more information on these products, you can go to our website at www.analog.com/iCoupler. Isolation provides a safety barrier for people and a noise barrier for instrumentation. The problem has been that once you transfer data to the secondary, you also have to get power to the secondary in order to run the interface. This has traditionally been done with either isolated DC-DC converters or offline AC-DC converters. These can be big, expensive, and hard to get certified. ADI has leveraged their microtransformer technology developed for the iCoupler to create the world's smallest UL-certified DC-DC converter, and we can build it right into our new iCoupler products, making ISO Power devices. The ADUM 5000 is a power-only module. It includes no data channels. The ADUM 52OX is a two-channel data module. Each channel can run up to 25 megabits per second. The ADUM 540X includes 4 data channels. Each can run up to 25 megabits per second. All of these modules are able to make 3 volts or 5 volt power from a 3 volt or 5 volt source. For simplicity, let's focus on the ADUM 5000 since it's the power supply only module and we're focusing on that aspect of our products today. The way that our DC-DC converters work is we have a very high frequency, 180 megahertz input oscillator that switches current into our microtransformers. This high frequency is required in order to get good transfer across these tiny coils. The signal is then received at the secondary where it's rectified and sent into a regulation control circuit. The regulation control circuit creates a PWM style pulse which is sent back through a dedicated iCoupler channel to the primary where it modulates the oscillator on and off to control the output voltage. The set points can be selected by the customer to either be 3.3 or 5 volts. Here we have a cutaway of our SO16 wide package containing the 4 die that make up a standard ISO Power iCoupler. You see here are the 2 large coils used for the power transformer. Below them is the feedback iCoupler channel, which provides the PWM signal from the secondary to the primary. These other coils down here are actually the 4 channels for one of our quad iCoupler devices. The oscillator and the rectifier and control circuits are all built onto a standard silicon die shown here, and the entire structure is wire bonded together and packaged. If we look at the actual currents and voltages inside the part, there are 2 main signal paths that we need to worry about. One is the actual current going through the transformer, which is made up of bursts of 5.6 nanosecond pulses to go through the small transformers. These are under the control of the regulation control signal coming from the regulator on the secondary side. I have the scope set up to actually look at a regulation control signal from our ADUM 5000 part on this demo board. And as you can see, as I change the load, the PWM changes the on time for the oscillator and hence the power to the secondary. Moving back to the block diagram of the ADUM 5000, we can see that this regulation control signal gives us a great deal of flexibility in how we can handle power, because we can take that RC out, or that regulation control, and provide it to the outside world to the RC out pin, which allows this device to act as a master controlling other iCouplers with ISO Power. We can also accept a regulation control signal from an external device, allowing this to become a slave to another device. This gives us a great deal of flexibility in combining these devices at the secondary side. Let's look at a couple of different examples of power configurations. Here we have 2 devices where one is set as a master and the second is set as a slave. It takes one input voltage source, the master regulates the slave, and both of the outputs can be safely combined to double the power. If we look over here, you can set 2 devices both as a master and combine their outputs in series to create a higher voltage rail, input 5, output 10. You could also ground the part here and make symmetrical +5, -5 volt rails. The possibilities are endless for combining channels and power configurations in these devices.